disaster like gas leaks, or we can have disaster like earthquake, avalanche, where the delta is very very less. So in these scenarios, we need a medium that is like quite real time in nature. So this is where the cell broadcast comes in. So it enables the real time mass broadcast messaging to the mobile phones in the targeted area. This technology has also been recognized as a crucial element by UN, and also our Prime Minister 10-point agenda for the disaster risk reduction specifies and mention about the leveraging of IT solutions and technology. So this cell broadcast technology, as we were talking about, is a standardized technology that is a broadcast based dissemination. It is geo targeted, so I can just geo target a particular area and ensure only the people in the particular area receives the alert. This is independent of network congestion, so this is a key highlighting factor. So if we talk about SMS and all the existing scenarios, in a time of disaster the network gets choked. So in this scenario, this technology holds the upper hand, and as this is a network congestion independent. Also this covers the roamers, so all my tourist population, the migrators, all everyone comes under the scope, and everyone who is there in the impacted region receives the alert. So if we talk about the early framework that existed, so a major dependence was on the SMS and mobile app based alerts. So as I said, SMS following a sequential delivery, and having a technical limitation of delays when targeting a large mass of people. And if we talk about the app on the other hand required pre-installations, subscription-based models, and uh, app download must be there in the phones. So these dependencies existed, due to which the end-to-end penetration of the alert information was not on a higher side. Also, the India's huge telecom ecosystem, it was like quite heterogeneous in nature, with multiple technologies like 2G, 3G, 4G, 5G, and also as a phase wise deployment. This ecosystem is comprising of multiple OEMs. So these are the challenges that was there existing in the Indian scenario. Also the population density, the linguistic density, the social economic diversity in India is quite high, from north to south, east to west. We have like multiple languages, like as per 22nd schedule, 8th schedule of constitution, we have 22 languages as per the constitution. Also, only a few of the vendors existed worldwide which provided such solutions. But considering the India's landscape, the huge tele density, the population density, the cost of those such solutions were ex- exponentially very high. And also, there was no indigenous secure system existed for Indian scenario. So this is a brief overview of how the solution is. So on the left, you can see there we have sensors for different disasters. So we already have agencies like IMD, the meteorological agencies, CWC as the hydrological agencies. So these agencies are already existing. They have their sensors which sense a particular disaster situation, and as and when they sense, they are integrated onto the national emergency platform, by which they can trigger the alert over the area, and this alert travels to the CBC that we have developed. So this particular network, the network node CBC, has been placed inside the telecom networks, and we have the gateways that interface it with the respective elements of 2G, 3G, 4G, and 5G. And once the alert is formed and disseminated, it reaches to the public, the end node, via the radio network controllers. So, as we said about the innovation journey, like the earlier challenge that existed was there was no depend. There was all dependence on manual channels. There was no end-to-end integrated framework, no specific geo-targeted capability in the earlier systems. It was all a fragmented ecosystem. Then came the cap-based alerting platform that we know as by the name of Sachet. So this enabled the functionality of SMS and mobile apps. So the it improved disaster alerting via the SMS and mobile app methods, but inherently these technologies also had limitation of delays and dependencies like pre-installations, subscription-based models, and such scenarios. So these challenges was overcome when we introduced the cell broadcast technology. So this technology being independent of network congestion, it's a real-time alerting, especially making a useful for the rapid onset disaster. It does not require any internet or subscriber database, and it works across all the technologies 2G, 3G, 4G, and 5G. So talking about the innovation journey, like this started with the testing since 2023, and by 2025 we integrated all of the India. So as I said, India has a like very vast ecosystem. There were like 1.45 crores telecom towers. This solution is integrated with all the five TSPs that we have in India, and this has been used across various states for actual disasters. So like for the cyclone Montha that came last year, it was used by Andhra Pradesh and Odisha. In Uttarakhand, it was recently used for heavy rain scenarios, and in recent weeks it is being currently being used by Uttar Pradesh and Madhya Pradesh for the heat wave scenarios. The solution has also been recently launched, and a pan-India exercise has been done. So on 2nd of May, this exercise was done where the alerts were triggered across entire pan-India across all technologies, and the users received the alert. So it was also covered across various media, and many of the people received those cell broadcast alerts. It was done as an awareness exercise by the government of India, and our Minister of Communication, Shri Jyotiraditya M. Scindia, launched the system. Talking about the achievements, this solution has also been tested and piloted in international countries. So we have the pilots done in El Salvador, Mauritius, Sri Lanka, and Cambodia, so which clearly indicates its global applicability, and it can very swiftly work in the international ecosystems. The solution has also achieved various awards, with the most prestigious being the WSIS award in 2024. Then we also received the Deen Dayal Upadhyay Telecom Excellence Award by the Department of Telecommunications for telecom excellence. And recently we got the Scotch Award 2025 in the gold category for e-governance. Talking about the existing solutions, so there exist other solution also, the foreign solution, but what makes us stand apart from them is the cost effectiveness. The solution developed by CDOT is explicitly optimized for large scale alert dissemination, since India has a very huge landscape with a different ecosystem. So if I talk about the telecom ecosystem in India, we have more than 1.45 crore towers, and more than 3100 of the RAN controllers. So we have the controllers from Huawei, Nokia, Alcatel, Ericsson. So it's a multi heterogeneous ecosystem. So we have the interlocking gateways which can integrate with any of the OEMs, and we can utilize this functionality of cell broadcast. So this solution has received certifications from TEC. We have confirmed to the essential requirements. It is also recognized as the trusted telecom product by NSCS. We have the certain certified security compliances and copyrights. Also, you can see we have certifications from the TSP, like from the Indian TSP, that this has been integrated. For the international POCs that we have done, we have received the certificates from the TSPs also, like you can Cellcard, Medphone, and the respective government agencies of Sri Lanka, Mauritius, and El Salvador. So, as said, this aligns with the global initiatives like Early Warning for All, which plans to cover the world by early warning system by the end of 2027. The solution has been integrated with all major TSPs in India. So you can see we have been integrated with Airtel, Vodafone, Jio, BSNL, and MTNL. So that's all with my PPT. So the floor is open to questions. So I request the jury members for any.
Very well presented, Mr. Anurag. And jury, you can start the Q&A session.
Anurag, this is R.K. Upadhyay, former CMD BSNL.
Hi, sir.
This is a fantastic solution, and congratulations for implementing this indigenously, 100% indigenously at minimal cost. If you have to point out a single innovation, single element of it, because since you are involved in this from very beginning, my question is that if you have to point out a single innovation in this, particular in developing this product and successfully implementing it, what would that be?
Sir, if it is about a single innovation, I'll talk about the interworking gateways. So as I said, the ecosystem in India was heterogeneous. And if I talk about the 2G elements, so 2G elements were such, they had no AMCs, so they were very less support. So it was all enabled the cell broadcast functionality by uplifting them, like we integrated with the interlocking gateways. So we enabled the CB functionality in those equipments with the no AMC support and all. So the interworking gateways was one such innovation that empowered us to have this functionality across all technologies, all OEMs.
You were able to get APIs even for the older systems like 2G, etc. I mean, how have you integrated? Did you use API route?
No, sir. So if there's particular interfaces like CBSP interface is there.
Okay.
So we make the use of those interfaces.
Good. Good.
Do you install any hardware on the BTSs or on switches? I mean, how do you do? Is it all software play?
Yes, sir. It's entirely all software.
Okay. And how is this technology? I mean, I think Upadhyayji also asked, how is it different from what is done elsewhere? It's cheaper because it's ours and everything is fine. But is there a technological architectural change you have done, which has led to its widespread deployment as lower cost? I'm talking pure technology.
Fine, sir. So, sir, talking about the uniqueness and how we stand apart. So, sir, if we look at the other solutions, so these solutions deployed in the developed countries. So, what the telecom ecosystem of developed countries looks like, they have a standard uniform 4G, 5G network and a latest of the RAN equipments. So, they don't have such a obsolete or the
ऐसा
previous
नहीं है,
version.
एकदम ऐसा नहीं है। एनीवे आप बोलिए वहां पे हमसे ज्यादा ऑब्सोलीट चीजें होती हैं। एनीवे ठीक
Fine,
है।
but
आई जस्ट
those
वांटेड टू
solutions.
अंडरस्टैंड योर
Hmm.
स्पेसिफिक या
But those solutions that they have developed and they are being used, they are not optimized at a scale that we have in India.
Yes.
So
Yes.
ओके
in India, we have multiple of RAN variants, and in the number of OEM that we have, in the same OEM, we have different models and variants. So these optimization is not there.
So
Talking about
in
the
your, just 1 second. So in your software, you have a separate module for each of these, like 2G,
right,
3G, 4G, 5G. Okay.
huh,
And so they only have 4G or 5G. You have 2G and 3G as well. So basically, a little
right,
bit of extra load, but you are
hmm,
able to use.
right,
I
and
think that's good enough. Yeah.
fine, fine.
Anything else technologically, if you have done, that would be nice. Otherwise, I'll leave it.
Yes, sir. So the other thing I was talking about, the large scale optimization. So in India, if we look at the landscape, we have huge mass, and if we look at the recent usage also by UP and MP, so the alert are being transmitted on a very large scale. So we need to ensure that the end-to-end delivery is not impacted. So we
But
have
that is done by the operators, not you, right?
no, but sir, the end-to-end ecosystem, the optimization that we do, so that the deltas at every node, starting from the CBE where the alert is sent to the CBC, then to the to the gateways that we have made, then
Mm-hmm.
to the RAN controller. So the entire chain we have optimized it. We have done benchmarkings. We have done various test cases. We have improved those parameters so that end-to-end dismission time is very very less.
I have some more questions, but I'll request others to, if there is time left, I'll come back.
In most foreign countries, Anurag,
Sir,
normally an alarm sounds and then either a text message is sent and it's really a screaming alarm, you know. The guy is really jolted out of his senses when he gets that message.
Same here.
right, sir.
So are you sending a text message or are you sending
No,
a
sir.
voice message?
Both.
And
Yes.
Sir,
is there an
this
alarm that
exactly.
sounds?
This is exactly what you described. So this is not a SMS. This is a pop-up message. The cell broadcast is a technology where the phone will be showing a pop-up message. It will be accompanied by a distinctive alert tone. So on whatever screen you are, there will be a pop-up message, and until it is acknowledged by OK, it won't go off your screen. So this is the use case of a cell broadcast, that it ensures that the user attention is gathered. So we have the alert tone, we have the vibration cadence. Also on some handset, it also supports the readout. So whatever message that we transmit over the cell broadcast, the content is also read out by some phones. So these are few mechanisms that ensures the user attention. If it would have been SMS that was used earlier, so many times what happens is SMS is there,
They
user
don't
may
get.
not recognize it that we have received. So for rapid onset disasters like earthquake, lightning, flash floods, so we need such mechanism where we can quickly alert those people.
And are
Sandeep ji,
there,
recently,
sorry, go ahead.
recently, I think, Sandeep ji, recently they sent some alert. I think he was mentioning.
It was a
I
test.
did get, I think, somewhere in early May or something, or middle of the May.
Yes,
So
so
that was
2nd of May.
really alert,
Second
sir.
of May.
So it was
Okay.
really a big alert with the red kind of, this one. So we could hear that a complete different kind of, alarm sound kind of this one.
The other thing I wanted to ask is, are there any upward and downward linkages, like for example, NDRF, etc. There's some method of getting them into action, or a person who's impacted by the disaster, calls back or connects back to the location that they are stranded in or whatever. So while this is great as a communication mechanism, but that guy is already in a disaster situation, so I don't know how much it is going to impact him. So I'm telling you, I'm in Canada right now. So one of the things that they tend to communicate is that, if there is a kidnapped child or something, or
Yes,
they communicate some description of a terrorist on the loose or something like that, that sort of information is useful, because then people are on the lookout. But in India, if you're already in a disaster situation, you're in an earthquake or you're in a flood or whatever, I don't know why you probably don't need any more warnings, but you need access to
fine,
help.
sir. So,
Yeah,
sir, I'll
so
address this question. So, like in the case of earthquake that you mentioned, so generally earthquake is consisting of two waves, primary and secondary wave, and between the two waves there's like a 15-20 seconds gap. So these pockets, if utilized properly, the disasters, the impact can be reduced. So these are the rapid communication that we need. Also, if we look about the ongoing war situations, this particular technology is also used for the incoming missiles. So if the missile was detected, in the recent wars that we have, the global scenario that we see, the cell broadcast was explicitly used that if an incoming missile is detected, so the people are intimated so they can go into the bunkers, so to minimize the loss as far as possible. So this is the small pockets that we can use to minimize the losses.
And I think also in the post-disaster situation, this communication can be used for mitigation of the situation arising
Exactly,
out of
sir.
refugee camps and all that, to guide them to refugee camps.
Other one question, Anurag, how have you solved this multilingual diversity problem of India?
Fine. So, sir, this solution, it supports multiple vernacular languages. So the SDMA or the agency that is sending the alert, they can send alert in the regional language that is being spoken in the particular area.
So what is the structure? Are you centrally controlling it from a National Disaster Management Authority, or every state disaster management authority has been given operational control?
Yes, sir, exactly. Every state SDMA units, we have the SDMA units. So every state have these platform access. So they can send geo-targeted alerts. They can control the message that they want to send and in which area.
Hey, Anurag, do you use the radio network? So they give you some specific part of the spectrum dedicated to you. How do you, I mean, you are a priority. You said there is a congestion independent. That's probably because they've given you something specific. Or is it a priority, or is it your dedicated frequency to you?
So, sir, talking about that scenario, so we operate on control plane. So the control signalings that we have, we use those. So these are control signaling messages that we send. So data plane congestion is independent to us. So even if it gets congested, control plane signaling still works.
Right, that still works. Okay,
Right.
right. Okay, get it. All right, interesting.
Thank you very much. Very nice.
Thank you, sir.
Hey, so did you take any inspiration from the foreign technologies being used, and or is it like completely grounds up from CDOT?
So, sir, this actually started with a joint effort from we developed the CAP platform, the CAP Sachet that we sent. So we were in close coordination with DOT and NDMA, and as we saw a practical problem that was existing in the ecosystem, that's how we came to know about cell broadcast, and gradually we uplifted the systems. Like we since 2023 we are working on this. So it started with some small POCs, then gradually developed into a complete solution, and now it is launched pan India.
So it's a grounds up then. That's very good.
Right.
Yeah. Thank you. Thank you very much, Anurag. All the best.
Thank you, sir. Thank you.
Very well
All the
presented,
best.
Anurag. I wish you all the best for your future endeavors and for the result. Thank you.
Fine, sir. Thank you.
You can leave the presentation.
Fine, sir.